I ran so Leetcode question called jump gain. So in this question, we're given integer array nums, and we initialize at the array's first index, and each element in the array represents the maximum jump length from that specific location. So we want to return true if we can successfully reach the last index from the first index using the jumping methods, and otherwise false. Let's check example 1 to see what the question means. Example 1 has numbers array, these are 5 elements, right? So let's say we are starting at this 2. Then we can jump either to this position or this position because the jump length is 2. So let's say we choose to stop at these 3. Then what happens? If we want to jump from these 3, then we have 3 ways. One is jump here to here, here to here, or here to here. So see, if we choose to jump this 3 from this 4, then we're already arriving at the last index, right? That's why I return true, indicating we can finish this task. Okay, I think the problem description is quite straightforward. Now let's think about how to solve this problem. So in this problem, we are using the grid approach, which is very similar to the previous dynamic programming methods. Let me show you how to derive the solution using a simple graphical explanation. Let's say we have a numbers array equals to 2, 3, and 1, 1, 4. And for the grid approach, we initialize the current farthest point we can jump, which is the farthest point we can jump from the current position, right? And also we need the farthest point itself, which is the farthest point we can jump from all positions. And finally, we need I to record the index. So let's build a table for these methods. So it will be more straightforward to understand. Okay, so first we want to start at the beginning, right? So start here means numbers I is 2 and I should be 0. If that case, the current farthest point we can jump is I plus numbers I because we are jumping from I and plus the maximum jump length we can reach from I. 0 plus 2 gives us 2. Farthest point should be 2 also. And now let's move to the next element. So this 3. And now I is 1, number size 3, so 3 plus 1 gets 4. And this farthest point should be maximum between these 4 and these 2, right? So take the maximum, we get 4 here. Okay, now let's move to next position. Oh, sorry. Okay, now I get this one. The index is 2, and 1 plus 2 is 3. And maximum between these 3 and this 4 is also 4. Okay, now we're arriving at this position. So I is 3, and 1 plus 3 is 4. And this 4 and this 4 take the maximum. Yeah, 4. Okay. Finally, we are reaching the last element, which is 4. So index is 4, and the current should be 4 plus 4, which is 8. And now take the maximum between this 8 and this 4. We get 8. Okay, now finish the traversal through the entire array. The final thing we want to see is this one greater or equal to the length of nums. If that is the case, this means we have at least reached the last index, right, as we did in this example. So the only thing we want to do is to return true as our result. Okay, now finish the quick graphical explanation. Let's start the coding part. Okay, the first thing to initialize is the farthest point we can jump, initialize as 0. And then want to traverse the entire array for I in range length of nums. And the current farthest point we can jump is from I plus the jump length number I. And the farthest point that we did in previous DP or gradient approach is to take the maximum or the formal farthest point and current farthest point. And finally, let's return if the farthest point is greater or equal to the length of nums minus 1 with our Python indexation words. Okay, you see this project seemingly very simple, but here's another corner case to consider. So let's say for this example 2, we have this starting 0 in the middle, right? So if we jump this one, the only thing we can reach is to go to this 0. Then the farthest point is still at this 0, and we move the I pointer all the way, we'll see the I pointer and the farthest point will be both stuck at this 0, right? If that the case, since the jump length from this 0 is 0, we cannot jump out from this 0 to go to the other element, right? So we have to stop here, and we cannot complete the task to reach the last index. So, how to solve this corner case? Well, if I equals to the farthest point, this means there's kind of this stacking 0 in this scenario. So we have to immediately break this for loop because we cannot continue traversing anymore. Okay, so now finish this corner case, let's see the code, see it works. Okay, you see the time capacity memory usage with this solution quite efficient, right? And I think the code is relatively short and easy to understand. If you find this video helpful, please like this video and subscribe to my channel. Thank you for watching, and I'll see you next time.